Hello guys, my name is Dimpo and I'm going to show you how to do this equation. So the first thing you do is to say hore. When you see something like this where e is to the x, now we know e to the x, right? When x approaches infinity, also approaches infinity. But e to the minus x, when x approaches infinity, this is one of e to the x, which approaches 0. So when you see something like this, right, you already have to think hore the e to the x should be negative, because if it's not negative, it's gonna cause problems. So you can multiply by negative e to the x on the bottom and the top, which is multiplying by 1. So basically you'll have this e to the minus x over e to the minus x minus 1 dx. So you didn't change anything, you just multiply by e to the minus x on both sides, and e to the minus x times 1 is e to the minus x, e to the minus x times e to the x. So this times e to the minus x would be e x minus x, which is e to the 0, which equals to 1. So when you have this, you also have to think, okay, what is this then? Before going anywhere, we have to think about this right here. So we know from Euler that the sum to infinity of x equals n equals to 1 over n squared equals to y squared over 6. So therefore, this here is just minus of this identity. Therefore, it means that our solution here has to somehow have this type of solution. So that is the first one. So we need to have something that has a sigma term, which is sum to infinity. Now, integration and sum to infinity are slightly the same things. It is just that on sum to infinity, you have the thing of n, where n is a natural number, and integration is just small segments of that. So integration, if you have a graph, it will be these small segments of these. If we take these as quantized, so meaning each step is 1, then they become integration to infinity. But they become sum to infinity. But now we're not talking about sum to infinity, because we're talking about natural numbers, and the gap is too big between that. So we need to change this integration here to a sum to infinity. And to do that, you might realize that this is a familiar looking integration of the geometric sequence, meaning that s to infinity equals to a over 1 minus r, which equals to the sum n equals to 1 a r n minus 1 till infinity. So this is very similar to this, meaning that we're gonna turn this into that, and then we'll have this part that we need, and this we have to turn into it being this way. So let's do it. We're gonna have this 0 high x e minus x, then we have the minus that we needed, all over 1 minus e to the minus x dx, and then this is that, so we write it at that form, which is minus integration of this to infinity n equals to 1. A is x e minus x times r is e minus x, and this is n minus 1 dx. This will then equal to minus 0 infinity equals to 1 to infinity x, and then we're going to have this minus x, and then we're going to have a plus x, so we're going to have just e minus x n dx. And then once we have this, we can turn the integration and the sum to n equals to 1, 0 to infinity of x e to the minus x n dx. So now here you can use integration by parts, or you can use the gamma equation where I equals to integral of x. Okay, so I k x k minus 1 e to the x to the minus x dx equals to k minus 1 that. So we're gonna have that. Now we want to turn this into one equation, and how we do that, we use u substitution. When you use u substitution, we're gonna say u equals to x, and therefore du equals to dx times n. So we substitute here minus this, and fuck you man.